How far the signal has to go. Voyager 1 launched in 1977, and it is still transmitting. It is now more than 24 billion kilometers away, and the distance grows by about 1.5 million kilometers a day. It crossed out of the Sun's bubble of particles in 2012 into interstellar space. Radio travels at the speed of light, which makes the distance easy to feel. A command sent from Earth takes a little over 22.5 hours to arrive. The reply takes the same again. A single question and answer takes nearly 2 days, and that figure gets longer every day. The transmitter runs on about 22 watts, less than a dim household bulb. By the time it reaches Earth, the signal is fainter than almost anything else we listen for, and it is picked up by dish antennas tens of meters across. The power source is a slow one. Heat from decaying plutonium turned into electricity. It fades a little each year, and instruments have been switched off one by one to stretch what is left. The last of them will go quiet sometime in the 2030s. It also carries a gold-plated record with sounds and images from Earth. That part is often described as a message. It is more honest to call it a gesture. Nobody expects it to be found. Planets with no sun. Not every planet has a star. Some were thrown out of the system they formed in by a close pass with a larger planet. Others may have formed alone, out of a collapsing cloud too small to ignite into a star. Either way, they drift between the stars in permanent darkness. Finding something that emits almost no light against a black background is difficult. The main method is elegant. When a massive object passes almost exactly in front of a distant star, its gravity bends the starlight and briefly brightens it. The shape and length of that brightening tells you the mass of the thing that passed. That is how the first free-floating planetary mass objects were identified. The events are brief, they never repeat, and they require watching millions of stars to catch a few. Estimates of how many there are vary a great deal, and some of them are very large. I will not give you a confident number because the field has not settled on one. More recently, the James Webb Telescope found pairs of planetary mass objects drifting together in the Orion Nebula with no star between them. How pairs like that form is, at the moment, unexplained. Colder than empty space. The universe has a background temperature. It is the leftover heat of the early universe, spread evenly in every direction, and it sits at about 2.7 degrees above absolute zero. You would expect that to be the floor. Nothing sitting in space should be able to get colder than the space around it. One place is colder. The Boomerang Nebula is a dying star about 5,000 light-years away in the process of shedding its outer layers. That gas is not drifting off gently. It is being expelled very fast, and expanding gas cools as it expands. The same effect as a can of compressed air going cold in your hand, on an enormous scale and running continuously for over 1,000 years. Measurements put it at about 1 degree above absolute zero, colder than the background radiation that fills the rest of the universe. It is the coldest naturally occurring place anybody has measured. Colder places exist, but they are all in laboratories on Earth, made deliberately, and they last for fractions of a second. That is where we will stop. About 5,000 light-years out, at a cloud of gas that is quietly colder than the sky behind it.